Introduction to Matplotlib, Line and Bar Plots. Welcome! This lesson is for absolute beginners who want to learn how to make beautiful plots in Python using the Matplotlib library. We will start from the very basics and end with a mini-project using real-world time series data. By the end, you will be able to create line and bar charts confidently. Running the cell now. Let's set up our workspace and prepare to make plots. First, we import warnings and tell Python to ignore warning messages, so our notebook is easier to read. We will not see warnings pop up. Next, we bring in Matplotlib, a popular Python library for plotting data and making charts. We also import pandas. Pandas helps us load and handle data easily, especially for real-world datasets. Running the cell now. Try running this cell to check your imports. What is a plot? A plot is a picture that represents data. It helps people see patterns and trends instead of staring at numbers. In Python, plots are made with libraries like Matplotlib. The two most common plot types are line plots and bar plots. Running the cell now. Let's make our first plot using fake data. This example creates a simple line plot. Our x values are 1, 2, 3, and 4. The y values are doubled, 2, 4, 6, and 8. We add a title to name the plot. Titles help people quickly know what the plot is about. We label the horizontal axis as x values. We label the vertical axis as y values. Plt.show displays the plot right here in the notebook. Running the cell now. Try changing these numbers or titles to see what happens. Now, let's make a bar plot. Bar plots are great for comparing groups. This code draws a bar plot with 3 bars labeled A, B, and C. The heights of the bars show amounts, 10, 5, and 8. We give the plot a title. We label the categories below the bars. We label the side to show what the amounts mean. Plt.show draws the bars so we can see them. Running the cell now. Try changing the labels or numbers to make a new bar chart. Why plots matter? Plots make it easier to understand data and explain results to other people. A good plot can instantly show a trend that is hidden in a table of numbers. Soon, you will use real data from the real world. Running the cell now. Let's load a real-world dataset about monthly shampoo sales. This code sets things up to use real sales data. We give pandas the web address of the data and tell it to download it as a data frame. After loading, we check the size of the table by printing its shape. The shape tells us how many rows and columns we have. Next, we print the first 5 rows, so we can get a quick look at the data. This helps us see how the data looks before we plot it. The table gives us an idea of what information is inside. Running the cell now. Practice. Try repeating this with a different CSV file from the web. The month column is not in the right format for time series plots. Let's fix it now. We convert the month column to real date values using pandas. This makes plotting across time much easier and more accurate. The pd_date_ line creates a list of monthly dates starting in January 1901 for the number of rows we have. We turn this list into pandas datetime objects, which lets Matplotlib understand how to order them on a plot. We also rename the sales column to sales for easier access and to avoid confusion. Running the cell now. Working with date times is common with time series data. Let's finally plot these sales so you can see a pattern over time. Here we create a line plot that shows shampoo sales over several months. The figure size sets the width and height so everything fits nicely. We plot date on the x-axis and sales on the y-axis, and mark each point with a dot so the data is more visible. A descriptive title says what the plot is showing. We label the months at the bottom. Sales are labeled on the side. Grid equals true puts faint grid lines in the background so it is easier to read the chart. Tight underscore layout keeps labels from overlapping, making the image easy to read. plt.show displays our result. Running the cell now. Do you see any trends? Try zooming in or changing the title to practice. Now we will show the same data as bars. Bar plots make it easier to compare each month. We use plt.bar to make a bar chart with the sales numbers. Each month gets a bar, with labels showing the month and year. We choose a pleasant color for the bars. A descriptive title reminds people what they are seeing. Again, we label both axes, months and sales. We rotate the month labels so they do not get squished together. Tight underscore layout helps the labels fit. plt.show displays the finished bar plot. Running the cell now. Which plot do you prefer for spotting changes? Try changing colors. Choosing between line and bar plots. Line plots are great for showing trends over time. Bar plots are best for comparing single values or categories. You can use both in the same project depending on what you want to show. Running the cell now. It is easy to plot more than one line to compare different trends. Here, we show both the original sales data and a rolling average. Sales points have markers. The red dashed line shows a smoother trend, averaged over 3 months. Titles and labels still help explain the chart. plt.legend adds a box to help people tell the lines apart. Tight underscore layout and show finish the chart for us. Running the cell now. Try changing the number inside rolling to average over more months. We can highlight special points on our plots, like the month with the most sales. Max underscore month finds which month has the highest sales. Max underscore value holds the biggest sales number. We plot the line as usual, then use scatter to mark the highest month in bold red. This makes it easy for viewers to spot the record month instantly. Other labels and features stay the same. plt.show draws the updated plot with the highlight. Running the cell now. Can you highlight the lowest month too? Try editing this code to practice. Sometimes mistakes happen. Let's see what happens if we ask for a column that is not there. This code tries to plot data from a column that does not exist. Try and accept mean. Python will catch the error and print a clear message instead of crashing the notebook. In real projects, handling errors like this saves headaches. Running the cell now. Try changing the not a column to an existing column to see the difference. You can save any plot as an image file with just one extra line. plt.savefig writes your plot to an image file on your computer. This is useful when you want to put plots in slides, reports, or emails. plt.close prevents extra plots from showing accidentally. A message prints to confirm that the image file was saved. Running the cell now. Check the folder for shampoo underscore sales underscore plot.png after running this cell. Customizing colors and styles. Matplotlib lets you choose colors, markers, and line styles. Custom styles make a chart match your message or brand. Running the cell now. Let's try customizing the look of our plots. Setting color changes the line to green. A different marker puts a square at each data point. Line style chooses a dash dot pattern. This lets you make charts that are clear and easy for your audience to read. Try out different values to make charts your own. Running the cell now. Pick your favorite color and marker and try plotting again. Adding labels helps people see exact values, not just shapes. Here is a bar chart with numbers on top of each bar. We use a for loop to write the sales amount above each bar. Value labels can make charts more helpful, especially when people want to read the numbers. Try adjusting the space by changing the evil value. Styling can make your charts more professional or fun. Running the cell now. Tip: adding direct labels is great for presentations and slides. Let's make a plot using your own numbers. Type for numbers, separated by spaces. Input lets you type numbers to make a custom plot. Each space splits off a new number, then we turn them into integers. The x-axis just uses numbers for now. Try making up your own sales data and look at the line plot. This is a fun way to practice charting new trends. Running the cell now. Try entering different numbers and see how the plot changes. Mini project: compare two products. Imagine you manage two product lines. Let's pretend shampoo sales are one, and you invent a second set of numbers as the other. Running the cell now. We compare two products on the same chart. This code creates fake conditioner sales by making them a bit lower than shampoo sales. We use two different markers and colors to tell the products apart. The legend makes it clear which line is which. This is a classic way to compare trends between products in business. Now you can see which performed better each month. Running the cell now. Try adjusting the conditioner numbers to see what happens if it grows faster. Here we use a grouped bar chart to compare sales side by side. np.arrange creates positions along the x-axis for each month, so bars line up. We set a narrow bar width so two bars fit for each month. One color is for shampoo and one is for conditioner. Xticks puts months under the pairs of bars. Grouped bar charts help people quickly spot which product wins each month. Legends and color make it easy to compare. Running the cell now. Could you make a chart for 3 products? Give it a try. Challenge: your turn. Try making your very own plot from scratch. Use random numbers or real data, change colors, add labels, and try both line and bar charts. Experiment and do not be afraid of errors. Every mistake is a learning step. Running the cell now. Recap: what have we learned? How to make line and bar plots in Python. How to work with real data using pandas. How to label and style your charts. How to compare different trends and highlight results. You are ready to use Matplotlib in your next project. Running the cell now. Want more free lessons? Like and subscribe to our channel for more fun Python tutorials and step-by-step projects. Tell us in the comments what you want to learn next. Running the cell now. Practice, make a simple chart and share your result in the comments.